wanting to learn how to fly 3D and want to build yourself probably one of the best 3D flying homemade airplanes you'll ever come across, this is the video to watch. This airplane is built out of your dollar store foam board. Profile, definitely 3D based on the surfaces, the wings, size of the tail, the rudder, all those things. And you can build this plane for under $3. That's all you need is the foam board and a few little things outside of your radio gear. There's probably a lot of things that you have in your toolbox or in your junk drawer or whatever to you can use for push rods, all sorts of different things. And I'm going to show you what I do to build these scratches. This plane flies every maneuver that you could possibly imagine, and it takes one heck of a beating as well. You can plumb these planes 1,000 times, you know what I mean, and they're still very flyable. A friend of mine just started flying a month ago, and he started off with one of these little Park Zone Cubs, okay? Just out of the box, learning how to fly. He's got one of these things now. He's been flying it for 3 or 4 days, and it's just unbelievable the way this young guy is flying. Hovering, harriering, torque rolling. As far as the stuff outside of building the plane, being all the radio gear, etc., you'll find a Turnagee or equivalent 1050 or up to 1200 kilovolts will fly the absolute heck out of this plane. A 20 amp ESC. The servos are HXT 900s, and of course you'll need your receiver. And your battery pack, any LiPo 3-cell, at least 1,000 milliamps. If you start getting into the 12 or the 1,300 milliamps, start making the plane a little bit heavy. When this plane is all finished, built without the battery, you're going to have a plane that weighs under 10 ounces. This is your foam board, dollar store, $1.25, 2 sheets of this. This is 3/8. These sheets come in, they're 20 by 28, and that's it. 2 sheets of that. You're going to need a nice long straight edge. Either a pen or a pencil works as well. A very, very sharp utility knife. As far as tape is concerned, the nylon strip tape, that's just a Staples brand of tape. You can find that, and it's just nylon enforced. That's what you can use for all your hinging. And some CA and exciter, which you probably already have. If you don't, available at any hobby store. This is a medium grade. You don't want thin or thick. The medium is perfect. And of course a little square. Now, as you can see, I have the horizontal and vertical parts of the slabs are just, I have some die cuts on here, and I'm going to have all the dimensions of this at the end of the video, and a couple pictures of length and all the different things you're going to need to know in order to create that template. But essentially, I'm just, once you've got your template cut out, and we're just going to, now you want to keep that template, and then you start making changes from there, okay? So that's the horizontal, and there is the vertical part of the fuse. Now that vertical part, I bet you I've made 25 planes from that. Trace it out, and then we cut it out. Okay, so now you can see we've got 2 templates cut out. Just going to take a quick measurement and see what we've got. We're using 28 1/4, okay? 28 1/4, that's coming from the back part before your elevator all the way to the very tip of the fuse. And okay, so enough of that. So we know that it's 28 1/4 inches long. The actual horizontal stabilizer is 2.5 inches from this section to this section. And before that cuts off, that is 3 1/4 inches. 3 1/4 inches here, and at the very tip is going to be 5 1/4 inches. Okay, so 5 1/4 inches up here. Back to that measurement down here, 3 1/4, and that section, complete in length, should be roughly 25 1/2 inches before the horizontal stab. Now, you notice I've got a line here. This is actually cut out. And this actually just pops out of here. Very important that you have a very sharp knife. And the reason this is cut out is this is going to slide into the back part of the vertical slab. And this area that's cut out starts right at the beginning of the horizontal stab. Measure out the middles from here to here so you know exactly where the middle of the fuse is. Draw a line, and then you want that to be roughly 3/8 thick. So you can, this area here, this area that you're cutting out is going to be 3/8, which is the thickness of that slab. Okay, so there we have part A. The area for the firewall, that will depend on the size of motor you're using and what type of mount you're using. I just use a little tiny piece of 1/8 or 3/16 ply, just a little square, big enough to fit my motor mount that's attached to the brushless motor. Okay, on this part, what we're going to do is, of course, we're going to have the same length. Okay, now we're going to draw a template for the vertical part of the slab, and very important where the wing mounts in and where this part of the slab and that part of the tail are going to mount in. These two key points are very, very important. It's important that your wing should be, of course, center with your truss line, coming straight up into the middle of where you're cutting out your firewall. So essentially, once we have this diagram cut out, we want to slide these two pieces together. Okay, and this slides up right into that area. Hopefully you're getting that. Right there. And this is where our elevator we're going to attach and our rudder is going to be attached. It's going to go about 7 1/2 inches starting to whatever its total length of the wing is going to be in the back here. Very important note. This has to be this way, otherwise your plane is just going to, well, it's not going to fly correctly. So slide out like that. Let's talk a little bit about where this starts. Okay, this starts in the tail here, and that's going to measure out. I'm going to cut out 3 inches from here, and then I'm going to angle these off roughly at 45 degrees on the back of the tail. And the reason I do that is, you know, you want a lot of up and down control. Sometimes I even cut it down a little bit more, okay, but it becomes a little bit of a problem with your final hinge when you add your rudder. So you want to make sure you got a little bit of area here to be able to tape your rudder onto there. And you can actually, when you put this on your ply and trace it out, and stick it up a little bit higher in the ply and have this little dragger area come down a lot further. So you've got you know, some area to play with, and then you can change the size of your rudder as well. Where the canopy starts is going to start at 8 inches. And for thickness, we're running about 5 1/4 inches. So 5 1/4 inches all the way up to here. Then from the leading edge, about 8 inches, that's where we're going to make our canopy. And that's going to bow out to its highest point at roughly 14 inches. Now we're going to start tapering it back, and it's going to become part of the fuse at roughly 21 inches. Okay, so 8 inches straight. She starts beveling it up at roughly 45, and then curl it. You can sort of manipulate how you want your canopy to be. It's just important that you have a good reference point. The more that you take this back changes your C to G tremendously, so that's important. And then coming up to this mark at roughly 27 inches vertical, that's where I've got it cut off. And that tail, from the top to bottom on this particular die cut, is 8 inches. Okay. This area is 3 inches cut off here. Comes down straight. That's coming down roughly 2 3/4 of an inch, and beveling it off at 45% or 45 degrees. Then coming up and making a cut roughly 3 inches long, down 3/8 of an inch and back. So you have that nice little cutout, and then back at 45. Now, as far as your wing is concerned, you have to decide where you're going to place the wing. And like I said, around 7.5 inches is a really good, awesome 3D area for that wing to be. But first of all, we have to cut out the wing, and I'll give you a few tips on that.